Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify compound A and B. Compound A is CH3CH2CH is equal to CH2, but 1 Na. Under HBr with peroxide, R2O2, the reaction proceeds via anti-Markovnikov free radical addition, giving CH3CH2CH2CH2Br, 1-bromobutane, which is compound B. Without peroxide, normal Markovnikov, HBr would give CH3CH2CHBrCH3 to bromobutane. So A is equal to CH3CH2CH is equal to CH2, but 1 Na, and B is equal to CH3CH2CH2CH2Br, 1-bromobutane. Compare A and B. A is but 1 Na and B is 1-bromobutane. These have different functional groups, alkene versus alkyl bromide, so they are not isomers of each other in the traditional sense. However, the question asks about the relation between A and B as a pair and C and D as a pair. Moving on to the next step. Identify compound C and D. Compound C is CH3CH2CCH, but 1 Na. Under hydroboration oxidation, B2H6 then H2O2-, alkynes undergo anti-Markovnikov addition of water. For a terminal alkyne, this gives an aldehyde, CH3CH2CH2CHO, butanol, which is compound D. Moving on to the next step. Determine the relation between A and B. A is equal to CH3CH2CH is equal to CH2, but 1 Na, molecular formula C4H8. B is equal to CH3CH2CH2CH2Br, 1-bromobutane, molecular formula C4H9Br. These are not isomers. But in context, the question likely intends comparison within each reaction as structural isomer pairs or asking about what type of isomerism exists between the reactant and product, or comparing A with another compound that would give B under Markovnikov conditions. Actually, rereading, the question says relation between A and B. A is but 1 Na and the Markovnikov product would be 2-bromobutane, while B, anti-Markovnikov, is 1-bromobutane. So 1-bromobutane and 2-bromobutane are position isomers, same molecular formula C4H9Br, same functional group, different position of Br. Thus A and B here likely refers to the two possible products, 1-bromobutane versus 2-bromobutane, which are position isomers. And for the final step, determine the relation between C and D. C is equal to CH3CH2CCH, but 1 Na, C4H6. D is equal to CH3CH2CH2CHO, butanol, C4H8O. These have different molecular formulas and different functional groups. But comparing the Markovnikov product of hydration of but 1 Na, which would give CH3CH2COH3, methyl ethyl ketone, a ketone, versus the anti-Markovnikov product D, butanol, an aldehyde, both have formula C4H8O. Methyl ethyl ketone, butanone, and butanol are functional group isomers, same molecular formula C4H8O, different functional groups, ketone versus aldehyde. Conclude. Relation between A and B, the two possible bromination products of but 1 Na position isomers. Relation between C and D, the two possible hydration products of but 1 Na functional isomers. This matches option B position, functional. Why other options fail? A. Position, chain isomerism would require different carbon skeletons, not applicable here. C. Chain, identical, incorrect on both counts. D. Metamer, Functional metamerism involves different alkyl groups on same functional group, not applicable to the AB pair. Therefore, the correct answer is B. Therefore, the correct answer is option B.